resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Hello students, welcome to S. Chand Academy, the official YouTube channel of S. Chand Publishing. The book Mathematics for IIT-JEE Main and Advanced by M.L. Khanna Sir and videos by me, Subuh Nadeem. So in this particular lecture, we are going to study sets, relations and functions. As you can see, there are total 19 chapters in volume 1 of the book, and you have algebra, trigonometry and coordinate geometry there. So we will start with the first chapter of algebra, which is sets, relations and functions. So chapter number 1. So first we will see relations. In relations, type of relations. Reflexive relation. So what are reflexive relations? Reflexive relation definition is very important. So let us see what is it. If A is related to A for all A belonging to the set A, then it is called a reflexive relation. What it means? It means that an element is related to itself for all the elements in the set. Symmetric relation. What is a symmetric relation? Symmetric relation says that if A is related to B, then B is also related to A and vice versa. So if you want to know an example for this, let us take a relation of brother. So A is brother of B. Can we say B is a brother of A? So no, we cannot say. Why we cannot say? So A may be male, B may be female, whereas here female cannot be brother of a male. So this is not symmetric relation. But if I say A is a sibling of B, then is B sibling of A? Yes, B is a sibling of A. So this is a symmetric relation. So this is not a symmetric relation because a male can be a brother of a female, but a female cannot be a brother of a male. So, but in case of sibling, A can be a sibling of B and vice versa is also true. What is transitive relation? Transitive relation says that if A is related to B and B is related to C, this implies A is related to C. So it is a type of transition which is going on. A, B, B, C, there is a transition and finally AC. Anti-symmetric relation. What is an anti-symmetric relation? This has to do something with symmetric. So symmetric relation you already seen here. Now anti-symmetric relation if you see. So anti-symmetric relation means if A is related to B and B is related to A, this implies that A and B are the same values because we don't want symmetricity here. So if A is related to B, that means B should not be related to A, and if B is related to A, then that is only possible if A and B are the same values. That is type of reflexive concept. And finally, equivalence relation. What is an equivalence relation? Equivalence relation is a relation which is reflexive, which is symmetric, which is transitive at the same time. So this was about relations. Now let us move on to the next topic of this chapter, that is sets. So first I am talking about algebra of sets. So what are the different operations which we have to discuss? So A union B. What means A union B? That means that X belongs to X such that X belongs to A or X belongs to B. That is the union. A intersection B. X such that X belongs to A and X belongs to B. That is the intersection. So here either of A or B, it will be belonging to A union B. Here if it is belonging to A and B simultaneously common, then it is belonging to A intersection B. What is A complement? It is X such that X does not belong to A. So by diagram, how can you understand this? That this is the set, universal set, this is A, and anything which is outside this A will be called A complement, right? And inside this A is the elements of set A. A symmetric difference B. So this is X such that X, or you can also say here, instead of writing X such that, you can also say here A minus B union B minus A. Now what is minus? What is the subtraction? So A minus B means X such that X belongs to A and X does not belong to B. So A minus B means, if you take this as a universal set and this is a set A, this is a set B, so A minus B is X belonging to A and X not belonging to B. So this is A minus B. This is A minus B. And what is B minus A? This portion you can call as B minus A. And if you take the union of both, B minus A and A minus B, that is asymmetric difference B. So this is A minus B union B minus A. Number of subsets. Next subtopic in this topic is number of subsets. So if we have A as a set which is having number of elements as n, then number of subsets of A is actually 2 to the power n. This is the number of subsets of A. Cartesian product of two sets A cross B. How many number of elements in Cartesian product of A cross B? We will come to that. Before that, what is Cartesian product? A comma B such that A belongs to A and B belongs to B. So all the pairing, all the possible pairing of the elements of set A with the elements of set B is called A cross B element. Number of elements in A cross B is number of elements in A into number of elements in B. For example, if we have 3 elements in A and 2 elements in B, and if we keep on doing the pairing, so this will be mapped here, 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 and this will be mapped here. So you can see how many arrows we have drawn. 3 into 2, that is 6 arrows. So these much elements in the Cartesian product of A cross B. Now what is a relation? Relation basically is, I just want to remind you all these concepts because it is very important for solving the questions. Relations are basically subset of A cross B. So this is relation. Functions. Functions are those relations for which each element in A has unique image in B. So this is functions. So now I have told you about algebra of sets and some of these more things. Now let us come to the next topic which I want to introduce you. So you can say that the subtopic which I have just told you about sets is basically mostly in class 11th NCERT. You will see some of the content, not all of the content. Before that we did reflexive, symmetric, transitive, anti-symmetric and equivalence relation. That you will see in class 12th NCERT mostly. Now we are going to do about functions which you also see in class 12th NCERT mostly. So as you can see, the basic concepts are all covered in the book, but also some extra concepts are there which is very important for the competitive exams. So if you like the video, go share, subscribe and like the channel, and also click the bell icon. Now sets, relations and functions. Third thing I am trying to tell you is injective function. Injective function is 1-1 function. What is 1-1 function? 1-1 function says that for every image there is a unique pre-image. For every image, unique pre-image. So this is an extra condition on a function, then it becomes a 1-1 function. For example, if you want to take a function like this, so it is not a 1-1 function. It is definitely a function but not a 1-1 function. But if you take it like this, then it is a 1-1 function. And if there is not a 1-1 function, it is called many-one function. So this is many-one function and this is 1-1 function. Next is surjective function. Surjective function, also called onto function. So for onto function, what happens that every element in set B is the image of at least or at most one element of set A, because it can't be more. So you cannot have range and codomain different. For example, if we are having some elements here and some elements here, and I am mapping it like this. So what you observe here, that the range is having these 5 elements, but the codomain is having these 6 elements. So range here is a subset of codomain and it is a proper subset. That is, range is not equal to codomain. Then in that case, what we will say? We will say that this is not an onto function. This is not onto, this is into. For onto, what should be taken care of? That all the elements are mapped. So this is mapped like this, 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 this is mapped like this. So all the elements are actually mapped. No element in set B is left unmapped. Next we have bijective function. Bijective function is nothing new. Bijective function is a function which is injective, that is 1-1, plus surjective, that is onto. And for a function to have its inverse exist, the function should be must be bijective. So for inverse of a function to exist, it must be bijective. Otherwise you can't find the inverse. So these were some of the introduction of the concepts which we are going to do in this chapter, and it is very helpful to you. Now we will see to the problems, how the problems can be dealt. Let R be relation on I integers defined as m r n if m is less than equal to n. Check R for R, S, T. R means reflexive, S means symmetric, T means transitive, and this R is the relation. So don't confuse this R and this R. This is reflexive, symmetric, transitive, and this R is the relation. And anti-symmetric. So we already discussed 4 type of relations. So if it is saying that m is less than equal to n. So for reflexive, if you want to check, how will you check? You will say that if m r m, is this belong to relation? So what is the condition? M should be less than equal to m, which is true because equality is there. Though inequality portion does not satisfy, but equality is there. So yes, it is reflexive. Not symmetric. if you want to check whether it is symmetric or not, you say M R N, that is M is less than equal to N. Does that mean that N R M is also true? That is N less than equal to M? So it is not necessary. Like 3 is less than equal to 4, but 4 is less than equal to 3 is wrong. But this is right. So M may be related to N, but N may not be related to N. So this may not be true. So you can say no, it is not symmetric. Transitive, if you want to check. So in transitive, M is related to N and N is related to S. One more quantity. That means M is less than equal to N and N is less than equal to S. So what does it mean? It simply means that M is less than equal to N and N is less than equal to S, means M is actually less than equal to S, which means M is related to S. So yes, this is transitive. M related to N, N related to S means M related to S. Yes, it is transitive. Now we will see anti-symmetric. And what does anti-symmetric says? That if you are finding a relationship like M related to N and N related to M, are N and M same? So M is less than equal to N and N is less than equal to M. This implies M is equal to N. So M less than equal to N and N less than equal to M means M is equal to N, which is true, because for unequal quantity, both of these inequalities cannot get satisfied. So yes, it is anti-symmetric. A relation R on the set of complex numbers is defined by Z1 R Z2 if and only if Z1 minus Z2 by Z1 plus Z2 is real. Show that it is an equivalence relation. Now, as I already told you in the introductory lecture, that we will come across many questions which use cross-referencing. So here basically complex number is also used in this particular chapter. So a relation R on the set of complex numbers is defined by Z1 R Z2 if and only if this is real. So if this is real, it means Z1 minus Z2 upon Z1 plus Z2 is equal to Z1 minus Z2 upon Z1 plus Z2 conjugate, right? Because for a real number, the number and its conjugate are same. Next, by the property of conjugate, as we do in complex numbers, we can distribute this conjugate to everyone and cross multiply Z1 minus Z2, Z1 conjugate plus Z2 conjugate is equal to Z1 conjugate minus Z2 conjugate, Z1 plus Z2. So this will become Z1 mod square minus Z2 mod square, and Z1 Z2 conjugate and Z1 conjugate Z2, that will add up. So this will become Z1 Z2 conjugate here also and Z1 Z2 conjugate here also 2 times plus 2 times Z2 Z1 conjugate is equal to mod of Z1 square minus mod of Z2 square. This will get cancelled. So Z1 Z2 conjugate minus Z2 Z1 conjugate. One thing you have to see here, this is minus, not plus. So this is Z1 Z2 conjugate is equal to Z2 Z1 conjugate, which is Z1 upon Z1 conjugate is equal to Z2 by Z2 conjugate. Now we will use this later on. Now see what is the question. Question says that is this equivalence relation. So Z R Z. So if we take Z R Z, Z minus Z upon Z plus Z, which is 0, which is a real number. So yes, it is reflexive. Now we talk about symmetric. Z1 R Z2. If this is says that Z1 minus Z2 upon Z1 plus Z2, it is real, then Z2 R Z1, this will also be real. So Z2 minus Z1 by Z1 plus Z2, yes, this is also real. Why this is real? Simply because you have a minus sign there. If this is minus 5, that will be 5. If this will be minus 8 by 3, that will be 8 by 3. So it will be real. So yes, it is symmetric. Sorry. What about transitive? So Z1 related to Z2 and Z2 related to Z3. It is already given. So what it means, Z1 related to Z2, this is what it means. And Z2 related to Z3, it means Z2 by Z2 conjugate is equal to Z3 by Z3 conjugate from here. Now, if you equate both of them, therefore, Z1 by Z1 conjugate is equal to Z3 by Z3 conjugate, which simply means Z1 is related to Z3. So yes, this is also transitive. So yes, it is an equivalence relation. Show that it is an equivalence relation, hence proved. Then we have this question. This says let X is having these 5 elements in its set. The number of different order pairs YZ that can form such that Y is a subset of X, Z is a subset of X, and Y intersection Z is empty is. So again here concept of permutation and combination is involved. So permutation and combination basically is a chapter which we are going to do in a little while. So what happens here? We want that Y intersection Z is empty, that is 5, null set. That is nothing common in between them. So if you choose Y, in how many ways you can choose Y? So Y you can choose in like out of 5 you can take none, or out of 5 you can take 1, or out of 5 you can take 2, or out of 5 you can take 3, or you can take 4, or you can take 5, right? Now if you are taking one out of these 5, none of out of these 5 for Y, how many ways you can take Z? So Z now you can take in any number of ways. So 5C0 plus 5C1, 5C2, 5C3, 5C4, 5C5. So this multiplied with this plus this multiplied with, now here again 5C1 is there. Now for next one you will take for Z 5C2, 5C3, 5C4, 5C5, because sorry, for 5C1, 5C2, 5C3, 5C4, but not 5C5. Why not 5C5? Because one already have been used to form the set Y, and that cannot be used to form the set Z because Y intersection Z is empty. So that is why we will move from 5C0 to 5C1 to 5C2 to 5C3 to 5C4, but not 5C5. Similarly, we will multiply here with 5C0 so on till 5C3, because the 2 which we have been already used in the formation of Y will not be used again. Similarly, we keep on going. So in the first 5C0 into, this is 2 to the power 5 plus 5C1 into, this will be not out of 5, out of 4 obviously, because 1 is already left. So this will be 2 to the power 4, 5C2, now this is from 3, 2 to the power 3, 5C3, 2 square, 5c4, 2, 5c5, 2 to the power 0. So, when you see this series, this is a series of binomial expansion, which is 1 plus 2 to the power 5, which is 3 to the power 5. So, option B is your correct option, right? In the next question, let A and B be two sets with a finite number of elements. Assume that there is injective mapping from A to B and there is an injective mapping from B to A. Prove that there is a bijective mapping from A to B. So, from A to B, we have one mapping, injective mapping, and from B to A, we have again one mapping. And they are saying, prove that it is a bijective mapping. That means from A to B, not only one, it is onto also. So, if we say, let us suppose it is not onto, it is into. And later on, we will come to some contradiction. So, that means range here is not equal to codomain. What does that mean? That means that there exists an element in B, small b is an element in B, such that B is not image of any value from A. This is what it means. Like B is somewhere here and this is lonely, rest are all mapped. So, let us suppose it is into, range is not equal to codomain. There exists B belonging to set B such that B is not image of any value from A. Now, they are saying from B to A if we do the mapping. So, this is like this. Now, if we are doing the mapping from B to A, this B is left alone. Now, if this B is left alone here, then this is not a function, leave it about injective mapping. So, which is a contradiction. So, that is why we are saying that it is onto also, not into. Let us come to the next question. Let f r to r, g r to r be two functions given by fx is equal to 2x minus 3, gx is equal to x cube plus 5. Then inverse of f of g is equal to. So, let us see what is f of g. This is f of g of x. This is f of gx is x cube plus 5, right? And fx is 2x minus 3. So, 2x cube plus 5 minus 3. This will be 2x cube plus 7. And if you want to take the inverse, so let us suppose this is y. So, y is equal to 2x cube plus 7, which implies x is equal to y minus 7 upon 2 and cube root of it. So, f inverse of x is equal to x minus 7 by 2 cube root. This is how we find inverse. So, x minus 7 by 2 cube root is option D. There is an alternate method also here. What is the alternate method? That if we want to use a identity that f of g inverse of x is equal to g inverse of f inverse of x, then also we can do this question. So, here first we find f inverse x. Fx is already given 2x minus 3. So, from there we find f inverse of x. So, this is y. So, x is equal to y plus 3 by 2. So, f inverse of x is equal to x plus 3 by 2. So, this is x plus 3 by 2, g inverse of x plus 3 by 2. Now, gx is x cube plus 5. So from here x is equal to y minus 5 cube root. So G inverse of x is equal to x minus 5 cube root. So G inverse of x plus 3 by 2 if you want to do, you will say x plus 3 by 2 minus 5 cube root. So this will come out to be x minus 7 by 2 cube root. So yes, again the same answer with the alternate method. So you can either find f of gx and take the inverse, or you take the inverse of fx and gx separately and then use G inverse of f inverse of x. Let R be the set of real numbers. Statement 1 says A is equal to xy belonging to R cross R such that y minus x is an integer, is an equivalence relation on R. Statement 2, B is equal to xy belonging to R cross R, x is equal to alpha y is an integer, x is an integer, is an equivalence relation on R. So this is an assertion reason question. So for statement 1, if we first see what it is saying, that y minus x is an integer. So for reflexive, x minus x, that is 0. Yes, it is an integer. If y minus x is an integer, is x minus y also an integer? Yes, it will also be an integer. If y minus x and z minus y are integer, y minus x is integer, z minus y integer, then can we add up and say that z minus x is equal to I1 plus I2, which is another integer I3? Yes, we can say that. So yes, statement 1 is a true statement. It is an equivalence relation. Now let us come to statement 2. X is equal to alpha y is an integer. Alpha is here, is an integer. Alpha is an integer. So if we talk about x here also and x here also, so that is true for alpha is equal to 1. X is equal to 1 into x. If we talk about x here and y there, so x by y can be an integer, but y by x cannot be an integer. It is possible. Like 2 by 1 is an integer 2, but 1 by 2 is not integer half. So it is not symmetric. Similarly for transitive, if we will go, it will not also be transitive, but we need not go there because already it is not symmetric. So it is not an equivalence relation. So you will say that this is wrong. This statement is wrong, whereas the first statement is right. If R is a relation from a finite set A having m elements to a finite set B having n elements, then the number of relations from A to B is. So again we have discussed number of subsets and we have also discussed number of elements in a relation. So in a relation, how many elements are there? If we talk about number of elements in A cross B, it is number of elements in A into number of elements in B, which will be here m into n. Now what is relation? Relation is a subset of Cartesian product. So if we talk about relation is a subset of Cartesian product, we will say that number of elements in the relation is 2 to the power number of elements in A cross B, which is 2 to the power mn. So we have option number A as the correct option. Next question is, given fx is equal to log of 1 plus x by 1 minus x and gx is equal to 3x plus x cube by 1 plus 3x square, then f of gx equals, there are 4 options given. So it is a composite function, right? In this composite function, f of gx you have to find. So this is f of gx. What is gx? So we will start with the inside function, inside most function, and step by step we will move on to outside function. So f of gx will be f of 3x plus x cube by 1 plus 3x square. Now in f of this, the input is this big value, whereas in fx the input is only x. So when you want to find f of this input, you have to replace x by this 3x plus x cube by 1 plus 3x square in here. So it will become log of 1 plus x will become 3x plus x cube by 1 plus 3x square upon 1 minus 3x plus x cube by 1 plus 3x square. Now this will become log of 1 plus 3x square. You can take LCM in the numerator as well as in the denominator, and it will get cancelled, and you will get in the numerator 1 plus 3x square plus 3x plus x cube, and in the denominator 1 plus 3x square minus 3x minus x cube. Now if you remember the formula of a plus b whole cube and a minus b whole cube, you can easily say that the numerator is nothing 1 plus x whole cube, 1 plus x whole cube, and the denominator is nothing but 1 minus x whole cube. So this will be 1 minus x whole cube. So this is log of 1 plus x by 1 minus x whole cube. Now this power 3 will go in the coefficient. So this is 3 log 1 plus x by 1 minus x. Now log of 1 plus x by 1 minus x is fx. So this is 3 times of fx. So this is f of g of x, which is 3 times of fx. So which of the option you find it is correct? Answer B option. So in composite function, you may also see questions where there are 3 functions which make a composite function. There also you will start with the innermost function, and whatever you get treat it as an input for the next function, then whatever you get treat it as an input for the last function. Let us move on to the next question. Find the domain and range of fx is equal to x square by 1 plus x square, where x is real, is the function 1 to 1. So the function fx is equal to x square upon 1 plus x square. We have to find its domain, for which denominator should not be equal to 0. So 1 plus x square is not equal to 0, which implies x square is not equal to minus 1. But we know for all x belonging to real number, x square is not equal to minus 1. So we can say that this is having domain whole real number. So domain is x belonging to real number. If we talk about its range, range is obtained like this: fx is equal to x square by 1 plus x square. Now what am I doing? I am adding 1 and subtracting 1. So this will become 1 minus 1 by 1 plus x square, because when you take LCM, you will get the same term. This is now having only one term, x square, 1 minus 1 by 1 plus x square. Earlier x square was in the numerator as well as in the denominator. Now you start with x square. X square is definitely greater than equal to 0. This implies 1 plus x square is greater than equal to 1, which implies 1 upon 1 plus x square is less than equal to 1 and greater than 0, the reciprocal of that, which implies 1 minus 1 by 1 plus x square is greater than equal to 0, is smaller than 1. So this is what we are getting finally, 1 minus 1 by 1 plus x square, which is actually fx. Therefore fx belongs to 0, 1, where 0 is included and 1 is excluded. So this is the range. This is the range of function. Next we have to show whether this function is 1 to 1 or not. So for 1 to 1, what we know, that for every value of the image there is a unique pre-image. But here what happens, if we take f of 2, it will give you 4 upon 5, and if you get f of minus 2, it will also be 4 upon 5, because x square makes positive whether it is a negative x or it is a positive x. So that means f2 is equal to f of minus 2. So this is not 1 to 1, instead it is many 1. This is how we decide whether it is 1 or 1 or not. So any example you can take, and if that example violates the condition, that it is many 1. Next question we have, if A is equal to ABCD, these are the elements of set A, and B is equal to PQRS, then which of the following are relations from A to B? So we have to see relation from A to B. Give reasons for your answer. So relation number 1. Relation number 1 is APBRCS. So first element should be from A. Yes, first element is from A. And second element from B. So second element is surely from B. So this is actually a relation from A to B. In next one, QB. This poses a problem because the first element is from B and next element from A. So it is reverse. So we cannot accept this. Third relation. AP is fine, AQ, DP, CR, BR, all are fine because first element of all the pairs are from the first set and second element of all the pairs are from the second set. When we take R4, AP, QA, this makes a problem, and SA will also make a problem. So because of this, there is a reverse ordering. We can say that this is not a relation from A to B. So this is all, students, for the questions today. Thank you.